through. Alright, getting the rules up there so that we have the rules, them rules, them rules, them rules. That explain how logarithms manipulate. And let's see, we were looking at the logistic equation last time. I want to look at different log models. Sorry, get my notes back up on my little stand here in my other class notes. Yeah, let's look at some models. We're just going to be doing some examples today of different models. Hello, Billy. And I'll keep the rules up here as I get my notes together. Two seconds here. All right. I'm going to take some different models from the textbook and we'll work through them. Let me get over to my blackboard here. But again, these are always a good place to start your thinking from when dealing with logarithms or exponents. It is our magical sauce here that if I have some base and I take the log of that base towards it, I can pull the exponents down. The other thing is if I have something to a power in a logarithm, I can pull the power out front. And these things will help us manipulate more variables, or in the power, and we need to pull the variables down. All right. So I'm going to be looking mainly at examples from section 7, where we construct models. So in general, this is like the application of logistic models. Up some windows in here. It's very, very warm. All right. So I think we'll look at number 23, which uses a logistic curve, which I wanted to show. A logistic model. And so we're on page 491 in the book. And so it says, the following table shows the number of cell phone subscriptions in India in billions for the selected year. So we're going to have cell phone usage. I just jiggled about there. Sorry about that. Usage in billions for the years from 2005 on. And so what we get is 2005. The usage is 0.05 billion. 2006, the usage is 0.12, and I'll put the rest of the chart up here. I won't scream out each data point. So we're going to go all the way up to 2011, so I'll write my other data points here. And their values. And so we have cell phone usage for the number of cell phone youths. Since there's a population here that has a total number, we're going to look at a logistical model. There's some carrying capacity. An enclosed population or an enclosed environment is a usually good sign that you can use a carrying capacity. And so we need to solve for the variables in the carrying capacity. So we'll say usage from time. Now I'm going to measure time. I'm going to call this year 0. And this year 1, and this year 2, and this year 3, and so on. On a count time from 2005. So we can kind of say, hey, time 0 is at 2005. So if I ever solve for t, if I get an answer of 9 for t, 2005 plus 9 would be in 2014, right? It just makes the number smaller and easier to deal with, to have some starting time. And logistic models are not bad. All right, so let's look at our general logistic equation. We have the carrying capacity of the population. Let's see, your book. Yeah, your book uses the same variables I had. Some books use different variables. I'm just making sure. Are they using a negative bx? Yes. All right, so what we can do is we can solve for a couple different points of data. And we can find these constants by solving for a couple different points of data. All right, so then what we want to do here is look at what this carrying capacity is first. So notice, if I made a small nomenclature error. This is an x, this is t as time goes on. So let me fix that, sorry. Because this is the important part with the carrying capacity model. At time equals 0, we get 1 plus a, right? Because at time equals 0, this out here becomes 0, because b times 0 is 0, and e to the 0 is 1. So we get 1 plus a. Now, if t were to go towards infinity, t were to keep getting bigger and bigger and bigger and bigger and bigger, our graph of a negative exponential is it gets closer and closer to 0. So as time goes on, this part gets closer and closer to 0, which makes this c over 1. So it approaches some number. But very early on, when b times t is less than 1, this looks like a positive. It has a positive end to it. And so what we need to do is we need to find the b constant and the a constant. Well, at time equals 0, we know our answer is 0.05. So we can take this c, 1 plus a, oops, hit the wrong pen here, but we're getting there. 1 plus a is equal to 0.05. I'll cross multiply, so this becomes c equals 0.05 times 1 plus a. I will distribute 0.05 plus 0.05a is equal to c. All right, so I have 3 unknowns. I'm going to need 3 points in this equation to help me find it. So I'm going to take this. I guess I'll keep this in yellow over here, and I'll find my next 2 in different colors so I can put them all together. Let's subtract this from both sides. So I'm going to get negative 0.05a. I'm going to leave a little space, plus c equals 0.05. I've taken this equation here, and I have a relationship for 2 of the things I don't know. All right, I'm going to switch over to blue, and I'm going to look at what happens when time equals 6. I want to go to the far end. I'm going to go to this one here. And so I'm going to have c over 1 plus a e to the negative 6b. And I know that's equal to 0.85. Let's go down. So again, I'm going to cross multiply. I'm going to get c is equal to, I'm going to multiply this through as I go, 0.85 plus 0.85a times e to the negative 6b. So I have, and I now have a and b in my equation, and I have c. Notice I have three things. So to figure out what a, b, and c are, I need 3 data points. So I'm going to grab one more, and then I have to put this all together. So let's grab my other one. I think I'll go, let's see, there's 6 of these, so I'll go right in the middle. I'll grab that one. So I'll say u of 3 is equal to c, 1 plus e to the negative 3b, and that's 0.14. Or 0.40. Not 14, sorry. Writing things but saying them odd. I hate when I do that. Do that a lot at the blackboard, where I'll be writing it and I say it. It's funny when you analyze your thought process of what you're writing versus what you're saying. Oh, I have my a out front here. My bad. So again, I'm going to cross multiply, and I get 0 equals 0.40 plus 0.40 a e to the negative 3b. All right, so I have 3 equations, and I'm going to write them down in their respective colors down below here. I have this one, and this one. So we're going to bring these together. So equation number 1, c equals 0.05 plus 0.05a. And equation number 2, c equals, where is the other one? 0.85 plus 0.85a e to the negative 6b. And equation number 3, c equals 0.40 plus 0.40 a to the e negative 3b. And so we have these 3 things going together. If we can find A, we know C immediately. So I think my focus is going to be figuring out how I can find B and A. So I can get rid of C in these other 2 equations. So for here, wherever I see C, I'm going to replace it with this. So number 2 becomes 0.05 plus 0.05a equals 0.85 plus 0.85a e to the negative 6b. And for the third one, 0.40 plus 0.40 a, whoops, I have to replace my C first, sorry about that. I'm replacing C, I went right to the equal sign, with 0.05 plus 0.05a is equal to 0.40 plus 0.40 a e to the negative 3b. Now there's a general rule of thumb in algebra. For every variable you don't know, you need that many equations. And so I have taken equation 1 and I've plopped it into equations 2 and 3. Notice I have gotten rid of the variable c. If I find a now, I will know what c is. So all my information is contained in these 2 equations. Well, I'm going to clean these up, and I'm going to try to separate a from b and my constants. So the thing I note is I have a constant here and a constant here, and a is in both of these terms. So I'm going to bring the a terms together on the left-hand side. So 0.05a minus 0.85 a e to the negative 6b. Right? I've subtracted this from this side, it brings it over to here. That's still sitting there. I'm going to subtract this over, so I'm going to get 0.85 minus 0.05 or 0.80. I subtract this over. And so equation 2 becomes this. Should have done that in blue. Well, I will fix that in a tick. That's nice because we can separate it. So I'm going to continue to work on equation 2. I'm just going to change it back to blue because I was being silly. Now notice both of these have an A in them. So I can pull out an A. 0.05 minus A. Whoops, I pulled out the A. E to the negative 6b equals 0.80. Where A is equal to 0.80 over 0.05 minus e to the negative 6b. So I manipulated equation 2 so that I have a term for A. Right? I took everything on the, I took equation 2, I put all the A's on the left-hand side. So I had 0.005A, and I subtracted from it 0.85A e to the negative 6b. I put all the constants on one side, so 0.85 minus, and I lost right here because I was rushing, because I was getting towards my point. Right, that's minus 0.85. That's minus 0.85. My apologies. I was rushing to the punchline. Let me get my eraser out and just tidy that up. Hold on 2 seconds. (0.05) minus 0.85 e to the negative 6b. Okay. So I subtracted this from the left-hand side. That gave me this expression. I subtracted this from the right-hand side. That gave me this new constant. I factored A out front because both of these terms had an A, right? That had an A term and that had an A term. And I divided both sides by this. So now I have A on its own. I'm going to do the same thing for I'm not even going to do the same thing for equation 3. I'm going to put this into equation 3. I'm going to put this into equation 3. And I'm going to do it in a way, I'm going to do the same rearrangement. And what we're going to want to do is we're going to want to get all of the B's together. All of the B's together. All right, so let's see here. There's equation 3, so I'll go back to green. And so I have 0.05. I'm going to subtract that from each side, and so 0.5a minus 0.40 a e to the negative 3b. All right, subtract that from both sides. And then I'll subtract the 0.05 from both sides, which gives me 0.35. I'll do the same thing. I'll factor out an A. 0.05 minus 0.40 e to the negative 3b equals 0.35. And A over there will equal 0.35 over 0.05 minus 0.40 e to the negative 3b. And so now equation 3 looks like this. And I've isolated A. And I've really got myself in a much better place because I have A, and c isolated in terms of the other variables. And so what I can do here is I can say this a has to be equal to this a. And so I'm going to blend these two equations together so they're going to turn purpley. If I say this, 0.80 divided by 0.05 minus 0.85 e to the negative 6b is equal 0.35 over 0.05 minus 0.40 e to the negative 3b. Now look what I've done. I only have one variable, it's b. I have gotten rid of multiple variable dependencies. I can solve b. Once I have b, I can go back here and find a. Once I have a, I can go back up to equation 1 and find c. So we will cross multiply. So I'm going to 0.8 times, so I'm cross multiplying these ways. So 0.8 times 0.05 minus 0.40 e to the negative 3b is equal to 0.35 times 0.05 minus 0.85 e to the negative 6b. Negative 6b. Right on the edge of my board there. All right, I'm going to propagate this number through. This is where your calculators are your friends. I did have a calculator that was my enemy once. I called him Robert. He beat me over the head with numbers. He tended to do it when I was asleep. So this multiplication becomes 0.04 minus 0.32 e to the negative 3b. And then this one becomes 0.0175 minus 0.2975 e to the negative 6b. All right, I'm going to get the terms that have e together. And I'm going to do that by adding this to both sides. So I get 0.2975. It's going to be positive coming over here. E to the negative 6b minus 0.32 e to the negative 3b. And I'm going to bring the constants together. I'm going to have this minus this. And this is a negative 0.0225. I'm getting closer. I've got my B up there, right? My B is separated, and I need to kind of find a way of getting my B all on its own. Which means we're going to have to dive into our rules of exponents and logarithms.